I apologize to this side of the room. Okay, they'll get that straightened out as soon as they can. My name is Simple Nomad. I am a hacker, belong to an organization called NMRC, and by day I work for View Corporation, who is kind enough to fund my existence and fly me around to all these places so I get to do all kinds of fun and exciting talks for everybody. This talk that I'm doing is the covering your tracks thing. What I'm doing with this is more of a proof of concept. I'm mainly wanting people to start thinking about these things. These tools are mainly meant to get across some general ideas to get people thinking, particularly the coders in the audience, to get them thinking. They're very simple tools, but the ideas behind them are probably a little more complex, and that's kind of more what I'm probably going to be touching on than actually showing how the tools themselves work. It's the idea behind the tools themselves. What we're talking about with this is stealth and covert communications. When I'm talking about covering your tracks, I'm talking about you're hiding your communications from someone. Okay? Now, you don't know who your enemies are specifically, but we can say that they're possibly an adversarial government, your existing government, maybe they're your so-called friends. You may have enemies. For whatever reason, you may want to be able to communicate in a secure and somewhat stealth fashion on the internet. And you want to be able to protect yourself, your assets. So that's essentially what this is, and I've kind of given you a little bit of the reason why you want to use it, and I'll touch on that a little bit later in the presentation as well. There are some examples of this kind of stuff as far as like file encryptors and decryptors go. PGP, GPG, and all that stuff that's out there is an extremely good example of that. Some of the, just any simple DES file encryptors, another good example. There are file encryption systems such as CFS, NTFS encryption. There's a number of different products and tools related to that. Steganography, outguess is probably the easiest to use and best example of STEG. Does everyone know what STEG? Anyone not know what STEG is? Good, a nice technical audience. And if you don't know and didn't want to raise your hand, then Google is your friend, so you don't have to embarrass yourself in front of this wonderful crowd. Covert network. What I'm talking about there is I'm talking about basically there's some type of traffic on the network that's going across, and your information is hidden within that traffic. Loki is a good example of that. There are some other ones. HTTP tunnel is one. And I know Todd McDermott he's done a lot of work with some of this stuff. He released some stuff at Rubicon and talked about some stuff that he's been doing with this kind of stuff. So there's plenty of information out there on that. The goals for this project is what I wanted to do. And when I say this project, I'm talking about basically this presentation to you to kind of talk about these things. One of the things I wanted to do is I wanted to be able to defeat not only network forensics to a certain extent. You can't get perfect with this, but you can start thinking in this direction. Also, I wanted to be able to defeat what I call workstation forensics, anti-forensics. I wanted, in case someone grabbed a hold of the box, I wanted to be able to keep them from being able to recover information off of the system. Okay? The other thing I wanted to do is I wanted these to be fairly simple to use utilities so I could be able to demonstrate these concepts to you. Make them to where they're going to install and they're going to compile with, you don't have to have extra libraries for any of this stuff, okay? It's all the code is all self-contained. I also wanted to leverage existing technology. Wherever I could find code that already existed out there on the internet that I could essentially well, I guess the technical term is you're borrowing and learning from that code. I basically stole a whole bunch of code and then, added some of my own stuff and threw it together. But that's something that all of us coders do. Immediately you go out and you look for, is there anything close to what I'm doing? I'm going to take that and then I'm going to alter it and make it suit my needs. First thing I wanted to talk about is a tool I'm calling ncovert. This is freeware. It is available. There is a broken version on your CDs. I'll give you the pointer to the fixed version. at the end of the presentation. No extra libraries are required. It's just using standard C. What I'm using to transmit data from one system to another is I'm using the initial sequence number. Okay, so the data is shoved into the initial sequence number, and essentially what this looks like, the traffic looks like, now just for demonstration purposes, it's not the greatest thing in the world, but it'll give you kind of an idea where I'm going with this. The thing that this can do is it can do anonymous sending. All right, right off the bat, the first thing you do is you do anonymous sending. So the packets that are coming out of your machine can be completely spoofed. The thing is the underlying TCP traffic that we're going to be using to move this information back and forth, we don't necessarily care about. Okay, it can fail. The port on the other end doesn't even have to be open. Okay, all we want to do is want to be able to get the packet across that has that initial sequence number in it. Okay, we can bypass most firewalls because we can control the IP address, we can control port numbers, and there's a couple of other interesting things we can do with this as well. One of the things we can do, okay, let me just kind of roughly explain how it works first off. And this is kind of, I'm not going to be able to do a demonstration of this particular mode, but this is basically how it is designed, and it does work. It's kind of neat. What I'm going to do is I'm going to send a SYN packet, it's going to have data in the ISN. I'm going to send it to a public server. Okay, let's say I send it to yahoo.com or google.com, whatever I want to send it to, someplace I know that the machine, say inside the firewall, can get out to. I'm going to send it to that public server. That public server, I'm going to forge the source IP, and I'm going to make that, the source IP is going to actually be the target where I want the packet, where I want the ISN to go. So what's going to happen is, packet goes to the server and receives the SYN ACK goes to the receiver's machine because I forged the source address. Okay? So then the receiver can then pick up the ISN out of that. The operating system is going to send a reset back to that anyway, and so it's going to close the connection on that server. Therefore, I'm able to bounce a message through that public server over to this receiver machine. Now, the interesting thing about it is when I go into receiver mode, I'm going into a sniffing mode. I'm sniffing for these packets. That's why I don't have to have the port open. Also, if the receiver packet, if it's coming back across my path where I'm sniffing from, then I can pick it up. Okay? So I don't even have to give the receiver's IP address. I just got to give the receiver's IP address, just has to be close. It has to be somewhere where he can sniff it as that packet comes flying by. And once I sniff that, then I can go ahead and grab it. And it's just going to go ahead and repeat that process until all the data is sent. Now, what is this going to look like in the logs? It depends on what kind of server. The public server is going to depend on what you're hitting. Okay? Odds are I would probably pick something like an IIS server. It's not going to log anything. Okay? So, no problem there. All right? And there's plenty of IIS servers out there that do just this. You could use other things too. I mean, you could use printers, just anything that's got an IP address where you can just bounce something off of and then get it to move that information over to the next system. There are some pros and cons to doing this. Pro is you can do anonymous sending, and you can do pseudo anonymous receiving actually, because you could, like I said, if you're sending it, all I care about is I want to get it to a Class C, and I'm sniffing that whole Class C. Let's say you're in cable modem land, and where it's all a party line, and you can sniff all your neighbors and whatnot. Then boom, you can get it right there into that general area. If you're lucky and you're farther upstream, let's say you're able to sniff everything going into a particular ISP, all you got to do is get that packet going by there. So you do have the ability to do anonymous sending and somewhat limited anonymous receiving. And I mentioned that there's anonymous receiving. Okay, if you're careful in your planning as to how you set all this up, as to how these packets are going to work, source address, destination, port numbers, which you can all specify with the ncovert thing, then you can bypass most firewall rules. Okay? And that's simply because most of the time, if you're inside somewhere, you're allowed out on port 80. So port 80 would be a good port to go out on, and then have that thing bounce back on another port. The cons of this is it's slow, and it's reliable as UDP. This is where, version 2 of this or whatever is going to actually try to improve some of this. But for right now, it's just as slow as UDP. It is plain text transmission, okay? And we're going to talk about what you can do to actually encrypt the data before you actually do the sending. Any file encryptor would work for that just fine. And I'll talk about some other things we could possibly do later on. What this needs, though, is multiple triggers. It would be nice when the receiver is using more than just saying, okay, I'm going to listen for packets coming from this particular IP address. If I added a little bit of crypto in there, let's say that maybe the first packet had the ISN was going to be some type of one-time pad. Or maybe I use a combination of flags in the headers, and I use a combination of the IP ID and a few other things. I could actually come up with a fairly interesting little scenario where if this value in this part of the packet header is equal to X and this value over here is Y, and then maybe everything matches up with some type of checksum, that's a given packet that I want to keep, and the rest I can throw away. And that way you can actually throw in some white noise in case you're still afraid this whole thing is being sniffed. You can throw in some false data in there, kind of wash it out. Also, it would be better if this thing was fully implemented underneath another type of running program. Implement this, possibly, this is a candidate for implementing into your stack. You have full control over your stack. Throw this into the IP stack, and then you have a really nice, neat thing. But that's and that's one of those things where I'm talking about. Concepts for you to take away for you coders out there to start thinking about, maybe start actually doing. I'm going to go ahead and show you what this looks like. And this isn't exactly I've got on this machine here, basically what I'm going to be doing is I'm going to be sending data. I'm going to be doing it all from this particular machine, but I'm forging the connection. I'm forging the source address to be this particular computer. I'm essentially going to move data from one IP address to the other. I apologize that they still haven't got that thing working. I'll explain what what's going on over here. What I've got is I've got two screens up here. What I'm going to do on this particular screen, I'm in a directory called temp2. I'm running ncovert. I'm running it in server mode. I'm listening on port 80, which is not open on this box, and I'm looking for something with the source address of .4, destination .7, and then this is the file name that I'm going to save this thing as. And then I'm essentially doing the same thing over in this other window. Pretty much the same thing, except I'm not in server mode, so it means I'm in client mode, and so I've got everything set. So what I do then is this thing is listening, and this thing starts sending data. I'm going to jump back and forth, and it's receiving over here. What I do, because I want to make sure, and the data's come across, and if you look here, let's see if I sent. I mean, a very simple file over here, and I purposely made it an odd size because I wanted to explain a little bit of this. So the file's been sent across. What happened in this is that I randomly was adjusting the IP ID on the outbound packet. However, the first IP ID, now this isn't an ideal situation here because obviously the first IP ID is 29. That's the size of the file. That's how I tell the other end what the size of the file is. It says, okay, my IP ID is this, and that's how I'm going to communicate that information across. Okay? So that's how that works. So that's how I say this is how big the file is. I can actually take that out if I want, but nonetheless that gets the information coming across, and there it is. You can see it. I've purposely made the file of 4As, 4Bs, 4Cs, so you can see there that it's the ISNs there are 41414141 and so on down to the end. And it's just a text file, so you get got a space tucked in there and a carriage return. So that's how that information is then moved across. Okay, now obviously I could expand this heavily. Okay, there's all kinds of little nice, neat little things I could do, all the various portions of those packets and headers and whatnot to make this fairly complex and a lot more robust. Okay, and this is one of these things where I'm hoping to actually sit down at some point, maybe during this conference or maybe during DEF CON with some of you might be interested in talking about some of this kind of stuff. Because essentially, I think you could expand this to the point where you could run an entire IP stack within an IP stack, so to speak. There's enough numbers and data and gobbledygook in those packets that you could actually run a separate IP implementation in there. And that might be kind of an interesting thing to play with. All right, let's get back over to the second part. Okay, encrypt. Again, we're talking about freeware here. There's no extra libraries that are required. Just use a standard C to compile. It is a symmetric file encryptor-decryptor program. If you have a choice, use the Unix version because it has more features in it than the Windows version does. There are a choice of 3 encryption algorithms. There are optional wiping of files, and this is kind of important, and I'll get into that in a second. But with the wiping of files, we also get the file slack on Unix, which is kind of important. There are 2 different wiping techniques that I use. You can choose to use either one, or if you're extraordinarily paranoid, you can use both. And I've tried to ensure some elements of secure coding in this. I welcome if you find bugs in it, that'd be great. I want it because I'd like for this thing to be halfway safe. This program is something that several people have contributed to this fairly heavily. Another NMRC individual named Inertia, who's sitting right over there, helped on the program fairly extensively. Todd McDermott sent some patches in to fix some things that needed to be fixed because he looked at an early version of the code, and all of the code that I took for this, because of the algorithms I used, I took code that was basically the same code that was submitted during the AES process. I figured that was a pretty safe bet. If I'm going to steal, well, not steal, but if I'm going to borrow the usage of crypto code, if I can borrow code that's being looked at by a whole bunch of security people during the AES process, then that code's probably in decent shape. Eventually, we will go through there and try and clean that up in case there's something in there that's screwed up. The encryption algorithms that I chose for this, I thought the AES process, which I'm one of these people that's fears and is the government and is frightened by almost everything they do. So I was nervous, but the whole AES process, it looked like it was on the up and up. That looked like a pretty interesting thing. You had a lot of input from academia, and so that I had a lot more confidence in that. And it was, which one do I pick? There were, looking at the comments from the AES process, it gets kind of hard to say, okay, well, this one looks good, this one doesn't. You kind of go back and forth. So I decided, well, I'll pick the top 3 candidates from the AES process, which was Rheindahl, Serpent, and Twofish. So if you have a preference then, for whatever reason, then you can go ahead and pick it. It defaults to use Rheindahl, or AES. Other parts of crypto that I use, when you put in your passphrase to encrypt something, it makes a SHA-1 of the passphrase. And then also, because I use there's some random material that does get generated during part of this. I'm using an implementation of Isaac for the random stuff instead of just using what comes with well, in my case, Linux. Let's talk about the wiping stuff in this. There's the first one I want to talk about, and I actually got to sit down and talk with a Peter Gutman about this a little bit when I was in Australia not too long ago. He wrote a paper in 1996 called Secure Deletion of Data from Magnetic and Solid State Memory. Has anyone read that paper? Anyone seen that? Yeah, a few bit heads in the audience raised their head. Kind of an old paper. It's probably fairly dated, and that works, I think, possibly both ways. Basically, when I'm talking about wiping files, what I'm talking about here, this is part of the anti-forensics of encrypt. One of the big problems you have when you're encrypting is a lot of times people will encrypt a file and then the original file in plain text is still sitting there in plain text. Okay, if you compromise that system, whether you're an adversary or you're the Fed BI and just grab the box and going to go look at all this stuff, the first thing you're going to look for the plain text versions of these encrypted files. Okay, deleting them, if you're just going to just delete them, they're still sitting there. The normal deletion process simply deletes the file, the first part of the file, the header that points to it. It can be recovered. Okay, so what you need to do if you're going to do encryption is, it is optional, give the opportunity to go ahead and delete the original during the encryption process. As soon as I've got the encrypted file on there, go ahead and do a secure wipe of that file. And not only do the wipe of the file itself and the data that it contains, but what's called file slack. That's kind of, because everything's stuck on there in the drive in blocks, and sometimes you may have been editing, so you may have the extra blocks out there that may have some of your plain text. So go ahead and get the file slack as well. Gutman's technique for wiping, and this was specifically designed to thwart TLAs, such as just any large governmental type organization, our government or whoever's, from recovering it. That was his original intention in this. He said 4 passes of random data. He had 27 passes of specific bit patterns that would write certain bit patterns onto the drive, layered on top of each other, 4 more passes with random data. You end up with 35 passes total, okay? That is probably overkill. In fact, Gutman himself says it is overkill because this was mainly intended for 1996 drives, older technology. Newer technology, the drives are a lot more reliable, and therefore you can probably get away with just probably just 2 or 3 passes of data on there. That was his recommendation. Even though that may be the case, there are still some paranoid elements out there. I am not making a commitment one way or the other on this, okay? I will just say it is possible that his information is dated. We don't know what type of, this is the thing you have to think about. You don't know what type of technology could possibly be used to grab data that's been wiped a few times off drives. We don't know what the capability is of various governments and nation states, what they're capable of recovering. Okay? So bearing that in mind, I mean, I don't necessarily, when I'm wiping files, I don't necessarily use this. Okay, for one thing, it takes freaking forever to do. But it's there. And like I said, if you want to use both wiping techniques, you can. The second one is actually a little more interesting. This one is, this was the standard that was developed by the NSA, the National Industrial Security Program Operating Manual, aka DoD 5220.22-M, subsection 3 or 8306. What that is, that has to do with wiping magnetic media, cleansing magnetic media. And what they recommend, and I actually got to speak with the person that wrote this section of it. He's no longer with the NSA, and he actually hangs around here at the Black Hat Conference. And I got to talk with him. He worked on this, and specifically what it is you make one pass with a character, you make another pass with the character's complement, with the bits flipped, and then you do a verified pass with random data. So you use 3 passes total of wiping the file. That is the government standard. There is no, if you see this advertised somewhere where they're saying we're using the government standard of wiping 7 times, that is bullshit, okay? That is made up marketing crap. I cannot find it anywhere. I have spoken to members of the U.S. government, and every time someone says, I think I know where this might be, they always end up pointing me back to this document. That's the only document I can find on that, and that's 3 passes. That's all it takes. The thing that's interesting about this is if you read the standard, it says that it's not intended for use on top secret data. Okay, you can use this on classified data, but you can't use it on top secret. Now, the thing there is that the reason they came up with this standard, the reason the NSA came up with this standard is this NSA person that he thought it was a big waste because every time they had a drive, they needed to put a new drive in, upgrade, or they needed a bigger drive in something, they would simply destroy the old drive through a whole series of, I don't know, melting and shredding and other things to the platter. That's fine, but the thing is that it's cost a lot of money. So he said, why don't we do this where we can actually save the U.S. taxpayers a little bit of money? And so this became approved for classified, but not top secret. So what does that mean? Does that mean that because maybe the NSA is capable of recovering stuff, if they put enough effort and time into it, they can get to data that's been wiped in this fashion? Possibly. Don't know. Question? Oh, okay. Well, if you could send that to me, that'd be great. That'd be great, because I'd like to know where that 7 came from. I mean, there's been people I know that are in, like, say, the FBI, that have said 7, and then I've asked them, where'd you get that information? And they don't know. I always end up getting pointed back to this document. But nonetheless, this document, this wiping part of it is in there. Some of the things that I've done into this to try to make the program as safe as I can is as soon as the plain text passphrase has been used, you enter it in twice when you're encrypting. As soon as it's used, I immediately remove it from memory. I immediately wipe it from memory as soon as I've got my SHA-1 hash. Okay? Because that's just as little time as possible do I want that plain text piece around. And I don't use the normal routines that the compiler may actually. I actually use my own. I pulled it out of a post that was on BugTrack a while back. Someone had a snippet of code saying that the compiler doesn't always, when you're doing certain types of optimization, it may not actually wipe some of your memory. So I have my own mem set that I use in this to do the wiping. After I have the SHA-1 hash, I have to generate a crypto key from that hash. As soon as I do that, get rid of the SHA-1 hash out of memory. Okay, because again, someone get that, then they're there. If you're root, then we memory lock it to prevent paging, so that way you're not paging parts of your passphrase onto the swap. Also, it prevents, like, say, plain text copies and stuff. It's not perfect, okay? Because, for example, if you're not root, it's not going to help you. And if someone else has root, they can probably get around it. Do I erase the SHA-1 state variable from memory? Jason, we will talk after this presentation. That's what I'm looking for. I'm looking for feedback. How do we go ahead and improve this stuff? Okay. The target users for this, I've got some listed here. If you have a shell account on ISP, and let's say this is a fairly typical usage of it, you want to make sure that you don't have that nosy ISP admin who has root, even though you know more than he does about how to run that box. You don't need him poking around your personal files. You can use this. You don't have to have some special crypto library loaded up on that system. You can upload your own code, compile it, and there you go. Some disadvantages is there may be stuff written to swap, and if he's actually really serious about snooping on your session there, he could actually possibly grab your passphrase as you type it in. So there still is some risk, but if he's right in there trying to do stuff against you, unless he's actually trying to sniff what's going on at that exact moment, you probably are not going to be able to, you're not going to be revealing anything to him. Another usage for this would be like a human rights worker, someone that's going to wants to encrypt some information. They want to make sure that that plain text version has been removed from there, so in case the evil foreign government or whatever is snarfing up laptops and looking for naughty behavior. Security professionals. A number of uses for this. Pen testers, for example, could use this if they've, let's say you've gone in and popped a box, and from that box inside you're doing Nmap scans, you're doing all this stuff, and now you're going to move some of the data back. Do you want to move that data back in plain text? No, you want to probably encrypt it. Okay, this is something that you could upload, run, compile, don't have to worry about extra libraries and whatnot, and then bring the data back. A privacy advocate, obviously, could think of a number of uses for using crypto, I would hope. And a black hat. I'm not going to beat around the bush. If you are someone that has something to hide, this is what this is for, so it is conceivable that black hats would actually use this type of thing. Defeating forensics, workstation forensics would be a good example of that. They want to make sure that, you know, the federales don't, you know, get their, I don't know, stolen porn passwords or whatever. So, so there you have it. This part of the demonstration is going to be rather boring, because all I'm doing is just encrypting a file. But I did want to show what the wiping stuff looks like. Oh, let's see what we got here. I may have this already in history. That'll make it a lot easier. Okay, I'm going to, with this, I'm going to encrypt. Let me turn on. I didn't specify what algorithm I'm using. I put in my passphrase. And there we go. Files encrypted. No big deal. Now let's say that I wanted to wipe the original during the process. Bingo. So that's basically how, as you can see, it doesn't take very long just to wipe that through, but I mean there was kind of a little bit of a delay as it went across that as we're wiping files. This also can do, let's see what else we got left out there. Let me do the, I've changed all these command things around real quick. Let me look. And always do this at home. Always check before you do this. Let me, you can just, okay, well, let me just look at this. This will kind of explain a lot. I'm glad I pulled this up. This will explain a lot. Basically, this is basically what you can do with the thing. You can, it tells you how to specify whether you're using you know, AES, Rheindoll, which is the same thing as AES, Serpent, Two Fish, etc. The Z mode, which is what I should have used because I wiped my original, which is why you need to be careful. If you specify the G or M mode, it'll go ahead and whatever the input file you specify. Or you can specify a whole string of files on there. It will not take wildcards. And that is simply because that's just adding that much more code to this thing probably what I will do, I've got it started, I haven't finished it. It was going to be nwipe, which simply did the wiping utility type stuff. There's actually already several, I haven't done it yet because there's already several wiping utilities out there already that do Gutman's thing. None of them do Gutman's and the military thing, so I will get it done eventually, but that's essentially the same type thing. But that kind of gives you, oh, what a lovely color we got going over there. Okay. That gives you a rough idea what we're talking about here with this. All right, now we're going to cover a few more things. Oh yeah, that's a real lovely color there. That's where encrypt is. I have not checked in the source code for the current version of encrypt, which is 0.6.4. Okay, but you do have 0.6.4 on the, it should be on the conference CD. Has anyone looked at their conference CDs to see what's on them? I sent the files in. They should be on the CD. I haven't checked myself, but they should be on there. And the ncovert version that's on the CD is 1.0. 1.1, you may want to write down this URL. Again, I apologize to this side of the room for that projector not working. And if you still can't get it, you can just email me and let me know. I put in some links in here to also for the that DoD 5220.22-M thing, as well as Gutman's paper. So you have some references there. That's pretty much all I have that I wanted to show you as far as the formal presentation goes. Again, the whole idea behind this was to get people thinking about protecting their files on their systems, regardless of who you perceive that enemy to be, because we really don't know specifically who the enemy might be. And really, if I'm going to use something that may be considered I hate to use the term military grade, but if I'm given the choice between XOR or military grade encryption, which one do you think you'd want to pick? You'd want to pick the best you can get. That's just me as a security guy talking about this kind of stuff. If I'm going to protect my files by making sure that the plain text versions are wiped, I want to use the best techniques that I can to clean those things up. Okay? Now, as far as the whole ncovert thing, now I can take those encrypted files and I can use ncovert and actually ship them out across. That has some powerful implications. I can take basically encrypted data and then ship it in a completely anonymous sending type fashion to another individual. That can be kind of that'd be kind of fun, kind of interesting. If the presentation, because I did update it slightly from the original one that you have in your printed material, because I changed it, where you can get the new ncovert and whatnot. I've updated the presentation. It is online right now. You can go out there to nmrc.org and tilde the gnome, and there it is. And I've got my email address on NMRC, as well as my BindView address up there if you have if you need to get a hold of me. Right now, we want to go ahead. We got we've got a lot of time. Let's go ahead and take some questions. They can be about this stuff here, about anything you want. Okay, just ask a question. I don't care. Yeah, right there. Yes, the question was, will the SYNAC get dropped if the receiver of the ncovert is behind a firewall? It will, a stateful firewall. Yes, it will get dropped. Yeah. Could you pad, the question is, could you then go ahead and pad the state table by having the receiver do some stuff? Yes, in particular, if you knew, as long as you knew everything ahead of time what was going to happen. Okay, you could possibly pad it. It depends on how inspectful the state is of this stateful inspection. If it's just looking at, if it's a simple type mechanism that's like, say, found in most implementations, most IP stacks, you know, where it's just, is this a part of an existing connection type thing, very easily you could do it that way. If it's something that's actually looking to match up sequence numbers or anything like that, then you may potentially have somewhat of a problem. Right here. That's very true. If you're, depending on if you're the source address, if you're spoofing, and that is correct. Obviously, what you have to do, what he's basically saying is that if I'm going through the firewall outbound and I'm using a forged IP address, if the person that set up the firewall has a clue, they're not going to allow that packet outbound because it's a forged packet. And that's one of those things that everyone is encouraged to do that administers these things. And obviously you'd have to test that. Now that doesn't necessarily mean that it's actually going to be the case. It could actually, and in most cases is not, particularly with ISPs. They are notorious for not doing proper ingress-egress filtering on their firewalls and whatnot. Yes, another question. Let me rephrase your question so that I think I got it right. You're talking about the fact that it's going to look fairly suspicious, me sending a single SYN packet or sending repeated SYN packets to one server, bouncing it off, it's coming back in here, and it doesn't look like that traffic's doing much. Why not implement it to where I'm bouncing it off of 8, 9, 10, 12, 100 different servers? Okay. Yes, that would be ideal because, yes, this is not perfect. Obviously, if someone's sniffing, this is going to be kind of an anomaly. All right, now there are ways that you could actually do some variations on this. I've thought of I mean, you could think of 100 different ways. One of them, yes, what you're talking about, bouncing it off of other servers, yes, that's a good idea. Now what that means is I'm going to have a little bit better identification of what's inside those packets. I'm going to have some type of potential crypto type thing happening in there, some type of signing of my packet to say this is a valid packet and this is packet number 5 and this is packet number 7 and whatnot, and eventually reassemble all that data back into my original file. Okay? Another way I could do it, which I probably am going to implement because it just sounds funny, is that I could do a port scan. Okay? I hide it, I make it look like a port scan. How many people here ignore port scans? Okay? They're irritating, you log them. Did it ever occur to you to check the ISNs to see if that's actually a whole bunch of scary covert data? No, probably not. Okay, most people would ignore a port scan. So I mean, there's a few different ways you can get around that, or like some of the stuff like a HTTP tunnel is another one. That's another example of something where it looks like HTTP traffic. Okay, and you're essentially tunneling whatever session you're running through there. Normally you'd run like SSH through it or whatnot, so that'd be encrypted. But you can run SSH over that. I mean, that'd be the same type of thing that you would go ahead and use some existing protocol. That's actually I'd actually talked about some of that stuff as far back as I think 98. What did I call that? I had a name for it. God, that's terrible. I came up with a great term and I can't remember the. Traffic pattern masking. That's what it is. Traffic pattern masking, making that traffic look like existing traffic, making it look like something broken. Okay. Another good example of doing something like that would be to take, say, a mail server. Use a mail server, and then what you're doing is you're talking to the mail server and you're making it look like there's some type of mail problem on the sender end. Okay. Go ahead and do a full connection. Okay. But make it look like there's a problem on the sender end, and so you got all this gobbledygook in there. And if you do it right on an Exchange server, it doesn't show up in the logs at all. Okay. You bail out halfway through a session. Typically, standard Exchange logs don't log it. Okay, send mail or something like that running on Unix, it will. But so there's a number of ways you can get around that. There's a whole myriad of possibilities doing that, moving data like that. Other questions? Adam. I didn't quite hear that. Oh, I'm taking the, okay, two questions. How am I using the SHA-1 key to get, say, my AES key? And I'm using the SHA-1 as a seed, basically, for that particular key. If you look at the source, you see there's a spot in there where basically you handed a key to encrypt with. And so that's what I'm doing. I'm handing it to SHA-1. Okay? Now, the random data, what he asked about, why am I using Isaac? Why am I using random data in there? I'm using that for the randomness when I'm wiping the files. I'm doing the file wipe. That's what the random part that's the main use for that. I'm not necessarily using that to generate anything that's used in the crypto process. I probably will have to now, thanks to Jason. But there you go. Over here, there's three guys with your hands up. You have to fight, and then. That is a very good question. Are there steps you can take to make sure the file is wiped on a journal file system? I forgot to mention and talk about that. If you're talking about a RAID device, you're talking about something that does a journal file system, those types of file systems are designed to essentially thwart what we're talking about doing here. They are designed to prevent loss of data on the drive. Okay? You can potentially, even if you're trying this wiping stuff, okay, there is no guarantee. I did do some anti-forensics as best I could. I could not recover this stuff like the normal stuff from the Corners toolkit and whatnot on Unix, on just using a normal file system. It wiped it fine. I could not recover the data using that. That was essentially my model. I did not have an electron microscope to go out there and look at the platters and see if there's some type of bit pattern that I could potentially use to recover. I didn't go that far because my boss is sitting back there in the back, won't let me have an electron microscope. Okay? I tried to expense it. No, it's nothing over $10 million in the expense. But so I'm not sure. Okay? I know I don't trust it on a journal file system or RAID or anything else like that. It automatically is going to try to save the data in some form or fashion to prevent exactly what we're trying to do. That's kind of a side effect of that. Something to keep in mind. That's why on systems that I have, where I have control over them, such as these laptops, I'm not using any type of journal file system. Because if I want to be able to wipe the files, I want them gone. Guy right next to you. Standard in or standard out? Actually, we tried that. Inertia had all kinds of difficulties trying to get that to work properly. Yeah, you can do it, but the thing is that all of a sudden the whole process of getting the passphrase in there makes it kind of difficult. We'll eventually get that worked out in some form or fashion where you can take standard in for the file and then pop it up. Yeah, that would be great because then you have ncovert take standard in and then you can just pipe the file through encrypt out through encovert and out onto its destination in one humongous ass long command line thing. But you know, that'd be fun. And behind you there. Oh, the bit lengths on the crypto. Okay, if I remember correctly without looking at the code, I'm almost positive that on Rheindahl, aka AES, is 256, 256-bit. Serpent is 256, and I think Twofish is 128 by default. You can go in and change the coding on that. And this is basically the way they were submitted to the whole AES process. I just basically took the way they were submitted. I figured that's probably how it was intended. Yes, you can alter that by going in there and tweaking the source if you want to make it bigger bit. 256-bit is fine. In fact, I've even toyed with the idea of doing a triple AES. You know, if you wanted to get nutso with this, why not go ahead and instead of supplying it with one passphrase, supply it with two. Confirm both, encrypt it with the first passphrase, encrypt it with the second, and then encrypt it with the first again. Okay, which essentially DES, or triple DES, that's what they do, and just essentially do that. I've thought about implementing, so doing a triple encrypt. That might be kind of a fun thing to do. I've been paying attention to this side a lot. Anyone over here? Okay, over here. IDS avoidance for encovert. Probably your best bets would be to use something like the whole traffic pattern masking. Make it look like something it's really not. That's why I like the port scan idea. You know, the IDS will pick it up as a port scan. Great. As long as they think that's all it is, then what do you care? They think it's just a port scan. So if you can hide the traffic itself to make it look like something else, then it probably won't matter. And then you just hope that it either gets thrown into the ignore it because there's too much of it, such as a port scan, or it looks like real data and it's ignored. Or even better yet, if you just make it look like some type of network error or whatever that's on some other end that they don't control, then that would also behoove you. So. Way in the back. Oh, that's a good suggestion. The suggestion was, for those who didn't hear, use a different spoofed source address, because when you're looking at those ISNs, normally they're going to be somewhat predictable, usually, to a certain extent. They may be randomly incremental, but they'll be incremental. They won't be jumping all over the place, or they won't potentially look like some type of data. Yeah, if you're doing spoofed sources like that, that'd be great. In fact, it's possible when you're bouncing all this traffic back somewhere else on the receiving end, if you get it to where it's source independent on the receiving end, you can have all kinds of different source addresses all coming to one machine, maybe even have them, random time delays in between them. Like I said, lots of possibilities you can play with this. This is just like a kind of a first stab to get people thinking about it. We had another question over here. I'm going to take about one or two more. Yeah. Okay. Question was, yes, two questions. First question was specifically journal. Right. Yeah, the first question had to do with crypto file systems. Actually, using a crypto file system makes more sense to a certain extent, because then all your files in there, as long as you're able to make sure that you had the whole secure wiping. I'm not paging to disk and, my whole super secret journal file system is all dumped out onto wherever. That actually would be better. And if you have that at hand to use, then go ahead and use it. Otherwise, I would go ahead and say, if you don't have that at hand, then just use something like this. Now, the second part, specifically, you're going to have to reword that.
My impression, maybe correct, is that there doesn't seem to be much attention generally paid to the correct file system. I just looked a number of times it just never seems like there's a lot of stuff that jumps out at you. I may be wrong about that, but I'm just curious why that was.
The impression was, it doesn't seem like, my guess is that it's not being used. Cryptographic file systems, they're not paying much attention to them, they're not using them very much. I'd say that's probably an accurate statement. It doesn't seem like that. You don't see people, like when I'm hanging out with friends and stuff, and it says, oh, I want to show you this cool program I'm working on. I don't see him type in a passphrase to unlock the file system. Okay, maybe he did it on boot up, I don't know. But typically you don't hear a lot about it. I'm surprised by that fact. I'm actually guilty of it to a certain extent myself. There's a lot of systems I have where I don't have the stuff sitting on encrypted volumes. Now, I do have a lot of stuff that is on encrypted volumes for that very reason. I usually use CFS with, there's a version floating around Blowfish in it, and that's typically what I would end up using. But yeah, that's, I don't know why that is. I think probably because it's just more work, it's more hassle. It's slower. It's a lot slower. And if you're doing some, if you're playing, if you're jumping between doing serious work and a serious game, that whole graphic-driven game thing is just going to slow the whole thing down. So people tend to not use it. I think we're just about out of time. I want to thank everyone for coming and attending the session. I appreciate it very much. Feel free to email me and whatnot. I hope you found this enjoyable. Thanks a lot. Appreciate it.